Hello friends, welcome to Smart Solution. In this video we will talk about what is load and stress on concrete. So when we say a load on beam, a load on column, or a stress in beam, a stress in column, what does it mean? So what is meant by load and stress on concrete? Whenever a concrete is faced with a load or stress upon it, how can we define it? So what types of stresses are there and loads are there? So this is going to be a very interesting topic and it's very informative. So before starting the video, I will request you to subscribe this channel and also hit the bell icon to have notification about my latest videos. And please watch this video till end because it's gonna be very important topic. So now let's start the video. So first let's define what is load or stress. So any force acting upon on concrete in per unit area is called load or stress. So any force which is acting upon concrete, like suppose this is called a beam and a load is acting upon in the middle portion of the beam. So this is creating tension inside the beam. So this is known as load and stress, and this is per unit tension. Like on this unit the load is creating tension in the middle of the beam, so this middle portion is called per unit area, so which causes deformation in the concrete structure. As you can see, the beam is bended down, so this is deformation in the beam. This load has three types. So how many types of this load? This load has three categories, three types, and the formula for calculation of this load is stress is equal to force divided by area. So we have to calculate the stress that is produced inside the beam. So we will simply force divided by area. How much force is applied, and how much upon how much area. So this will be stress will be calculated exactly. So this is the formula, and stress and load is calculated in PSI, which is pound force per square inch, and we'll read about it soon. So how many types of stresses are there? We will now talk about this. So different types of loads and stresses on concrete. So there are basically three types of stresses and loads which act upon concrete. The first one is compressive load. What is compressive load? The compressive load, any load which acts upon concrete from two opposite sides. As you can see in the picture, this is a cylindrical object and two forces applying on both sides but in the same direction. Like this force is acting upon in the same direction and this is also acting upon in the same direction. So in the opposite direction but on the same way. So what it means that two forces acting upon an object from two opposite sides but in the same way. So this causes the shrinkage of the object. As the two forces will move towards each other, the object will shrink. So this is known as shrinkage, and this force is called compressive stress, compressive load. So this type of load upon concrete column produces compression in the structure, in the concrete. So that's why it's known as compressive load. And what is the example of this load? It's like the floor we walk on. The floor is made up of PCC and it's concrete, and we put pressure upon the on the floor. So we create compressive stress. We create compressive stress and we are creating compressive load on the floor. So this is known as compressive load, and that's why a deformation we can see in the floor if the floor is not very good. So that's why this load is measured, and that's why the floor is prepared according to that bearing capacity. So compressive load is measured in PSI. This is not tensile load. This is compressive load is measured in PSI, pound force per square inch. So this is a unit to measure this load, and it's a small unit PSI, and MPa is a big unit. 1 MPa is equal to 145 PSI. So compressive load is measured in PSI and in mega PSI, in MPa, megapascal. So in MPa it's measured, or in PSI it's measured, pound force per square inch. So this is called compressive stress. The next type of load or stress is called tensile load. When two objects pull an object in the opposite direction, Any load which acts upon concrete from two opposite sides and in the opposite direction as well. So as you can see, these are two types of forces which acts upon from two opposite sides and in the opposite direction. This is the opposite direction, like both are moving against each other. So but they act upon an object from two opposite side. Like this object, this beam is facing tensile stress. So this object causes, this force is causes the expansion of object. The beam will expand, the beam will expand, or the beam will elongate. So this called this causes the expansion of the object. So similarly, tensile load is on contrary to compressive load. So concrete faces both tensile load and compressive load. That's why to make a concrete more strong, to face tensile strength, we provide steel bars in between. So that's why we put steel bar in between that, so the concrete should not break in the middle. And if the forces are applied like that, and that's why the steel bars are there to bear this load, this type of load, this type of tensile load. And the compressive to bear the compressive load, there's not much to worry, because the concrete compressive strength is already greater than its tensile strength. So concrete tensile bearing capacity is only 10% of the total capacity of compressive stress. So that's why steel bars are provided in structures where the concrete is facing more tensile stress, like in beams. So tensile load is also measured in psi, pound force per square inch, or in megapascal. 1 MPa is equal to 145 psi. So this is the second type of load upon concrete. The third and last type of stress or load upon concrete is called shear load. So any load which is upon concrete from two different opposite sides, like this object is a beam, and two forces are acting upon this object from two opposite sides. These are the two opposite sides, but from two opposite different sides. Like this force is acting upon here, and this force is acting upon the other edge of the beam. So these are two opposite forces, but they are acting also from two different sides, like not on these sides. So this is called shear forces, and these forces act upon in opposite direction as well. So their direction is opposite, so it causes the tearing of object. So these actually create the tearing of object in the middle. So because two forces are acting upon in the opposite direction, and these are creating a tearing in the object. Like the object will break from here, this portion wants to move here, and this portion is moving here by the force. So that's why it creates tearing or shear force in the object, in the beam. So this is known as shear load, and shear load is also measured in psi or MPa. So this is the same type of force like tensile force, but it's acting upon and from two different sides, from two different locations. So that's why it's different from tensile force, and it does not create the expansion of the object, but it creates the tearing of the object, and that's why it's different from the tensile load. So these are the three types of loads or stresses which works upon concrete, and it makes the concrete which damages the concrete, and that's why concrete is built according to face these type of stresses. Shear load to bear the shear load, and tensile load, and compressive load. So concrete is very good in bearing the compressive load, but not very good in tensile load. So that's why reinforcement or steel bars are provided in concrete to bear these two types of load, shearing load and shear load, and tensile load. For that, reinforcement are inserted inside the concrete. This is what we know as RCC, and PCC is very good against compressive load. So these are very important thing to know about concrete design, to know about concrete, how strong a concrete could be. So before building a specific type of concrete, and where should we build PCC or RCC depends upon these loads. So I hope this video would be helpful to you, and if you find it helpful, please like and share this video, and also subscribe to our channel Smart Solution. So I'll see you in the next video. Thanks for watching.